What? Oh, hi. In the last year, I was fortunate enough to travel to Asia a couple of times for my job and vacation. But every time I had to sit in a plane for 14 to 20 hours. So now I'm thinking, is teleportation possible? And how long till we can finally scrap our planes? While teleportation is a matter of science fiction at the moment, let's still talk about the three main ways teleportation could be possible. I will try to explain as simple as I can. The first method would be to use an Einstein-Rosen-Bridge. To understand how an Einstein-Rosen-Bridge works, let's very briefly talk about black and white holes. In the modern understanding of the universe, we do not live on a three-dimensional plane along a rigid time axis. We live in a four-dimensional world called space-time. You could call the axes length, height, width, and time. And like the other three dimensions, time is also subject to manipulation by outside forces like gravity. If you condense matter infinitely small, it will create a singularity. A black hole so massive that it converges space-time like a magnet deforms metal. A black hole has a very high gravitational pull, so much that it even sucks in light and deforms time itself. Beyond a certain point, which is called the event horizon, nothing can get out of a black hole, no matter how much energy you provide. If you were inside a black hole, time would be converged so hard that it would stop existing for you. Letting aside that you would be dead, you would be here literally for eternity. While black holes are proven and observable in our universe, their counterparts remain strictly hypothetical at the moment. White holes. A white hole has inverse properties of the black hole. While a black hole pulls everything inside, a white hole spits out matter and light. Beyond the event horizon, you cannot enter the white hole, no matter how much energy you use. Because a push is just the opposite of a pull, some scientists believe that a white hole is actually a black hole that is driving in reverse in time. This sounds weird, but think about the other axes that are easier for us to understand. If you intend to go forward in the length dimension, you take a step forward. If you reverse on the length dimension, you can do that by taking a step backwards, which is the reverse movement of a step forward. And the same way, you could think of a push to be the reverse motion of a pull in the time dimension. If a black hole and a white hole are linked, they can theoretically create an Einstein-Rosen-Bridge, a wormhole. You would be able to enter through the black hole and exit through the white hole. This way, teleportation would be a possibility. But immediately we can see several issues with this type of teleportation. Disregarding the fact that black holes are a cosmological phenomenon and white holes are purely hypothetical. If you could create a black and white hole, it would take a lot of energy to create and sustain them. Also, traveling is only possible one way. While you can enter into the black hole and leave through the white hole, there is no way to get back. For your return trip, you would still require a flight, possibly across multiple galaxies. The next issue is that there is no time inside a black hole, so you wouldn't know when you would come out of the other side. It could be immediately, in the future, or even in the past. Since we have no idea yet how time works inside a black hole, and if the laws of physics as we know them even apply inside. For you, the transport would still be instantaneous and therefore technically be teleportation. But the reason we want teleportation is to be at another location at an instant and from outside observers. For example, to visit your grandma in Japan at an instant. So not good for our purposes. Grammy can't wait this long. And lastly, you would die. You are being condensed into something that is way smaller than a salt grain. No way you come out of the other side and still be alive. So we can forget about wormholes. But I do have another idea. How about traveling faster than the speed of light? It may sound like science fiction, but when you move very fast, your time moves slower for you. This was proven by flying clocks around the world. Afterwards, the moving clocks showed a different time than the stationary clocks. The faster an object moves, the slower the time seems to pass for the object to an outside observer. How much is determined by the Lorentz factor. Let's say you are moving in a space shuttle at high speeds. The Lorentz factor describes how much the time perception changes from the outside observer to you. A factor of 0.5 would mean that the time for you passes half as fast as for an observer. The Lorentz factor is given by the equation gamma equals 1 over the square root of 1 minus v over c squared, whereas v is your velocity and c is the speed of light. At zero velocity, the Lorentz factor is at 1. That means that time moves as fast for you as for outsiders. The faster you move, the lower the Lorentz factor is. Therefore, time moves slower for you than for others. If you approach the speed of light, time would get slower and slower. If you accelerate to the speed of light, the time you experience drops to 0. Until now, you have been moving through space-time in both directions, in space and in time. But now, since the time you experience has dropped to 0, you are only moving through space, not through time. This is a very abstract sentence and may sound weird, and it is. So let me explain in another way to make it clearer. When you move towards north at 100 km per hour, you don't move towards any other direction. But if you move towards the northeast at 100 km per hour, you're actually moving to the north and to the east at 70.7 km per hour each. The same speed has split across the space axes. If you direct all your movement of 100 km per hour eastwards, then you won't be moving to the north at all. The same happens in space-time. We can switch the north and the east axis to time and space. We will pick a single space axis to make things easier. You are moving at a constant speed, the speed of light, but in different directions. If you stand still in space, then your whole speed goes into the time axis. That's why the time is normal for you. But the more you speed up in the space axis, the less speed you have in the time axis. But your total speed stays the same. So if you would speed through space at the speed of light, you would not be moving at all on your time axis, and time would stop for you. This has two implications when trying to accelerate past the speed of light to teleport. First, you are moving at terminal velocity, the speed of light. You cannot increase the speed, since your speed arrow has a fixed length, the speed of light. You are only changing the direction in space-time. And second, you cannot accelerate anymore, since there's no time to accelerate. Your time cannot slow down below 0. So with this method, we have two major issues. First, you need a crazy amount of energy to get to the speed of light, and you can only accelerate close to the speed of light. True teleportation would require an infinite speed. For teleportation on the Earth, this could still be viable though. If you were to accelerate to the speed of light, you could circle the Earth in 0.14 seconds. That is close enough to teleportation for me. This will only be an issue when we're talking about interstellar travel, through teleportation. However, the amount of energy needed to accelerate just you close to the speed of light would be about 4.5 times 10 to the power of 17 joule. That is approximately as much as 100 Hiroshima bombs. And second, you will never be able to travel faster than the speed of light, which means no teleportation in space. So, no travels at the speed of light anytime soon. The last possible method is using quantum teleportation, and here's how it works. First, your body is being scanned for its complete physical and chemical composition, like your luggage at the airport. This information is being transferred to your destination, where a supply of fitting matter is being used to rebuild your body, while your original body is being dissolved and fed into that location's matter supply, or be converted into pure energy. But how do you transfer the information to your destination? While on Earth this information can be transferred in a matter of milliseconds, it takes more time across multiple planets or galaxies. But using quantum entanglement, information can be transferred along any distance. How does quantum entanglement work? If two particles, for example protons, are being created at the same time, twinning may occur. That means that both particles always mimic each other, no matter how far apart they are. Why that happens, we don't know. That is for the string theorists to find out. But you can use this property to convey information. For example, by changing the spin, the direction of the rotation of one particle. The other one will change its rotation as well, without an outside force, other than you changing the entangled particle, and can therefore be used as a receiver for the information. This is called quantum teleportation, and by combining quantum teleportation to transmit the information across space-time with the dissolving and recombining of the material, you get a very real way of teleportation. That way, you can be scanned and dissolved. The information about your composition can be transferred instantaneously to your destination, and you can be rebuilt there, like the nanotech Iron Man suit. Sounds exciting and possible. With this method of teleportation, there is just one problem that is similar to our second method. Dissolving a human being into energy would produce an energy level of 9 times 10 to the power of 17 joule based on the Einstein equation E equals mc squared. That is evil, yeah. That is even double the amount needed to accelerate them. You would need a system in place to store all that energy. Also, since quantum entanglement is bound by the laws of physics, it's yet unclear if it will even be possible to use it for faster than light communication. So far, it has only been used for transmitting information over hundreds of kilometers. So while it seems that I will have to take the plane for the foreseeable future, it seems like the most realistic candidate for teleportation would be quantum teleportation. But there still are a lot of big ethical issues and open questions with quantum teleportation, like what happens to the soul? Or are you being killed in the process? But that's a topic for an upcoming video. If you don't want to miss that, make sure to subscribe. And please comment down below which mode of teleportation you would like to try out and why. Now I will teleport myself out and will not come back before you have given a like to this video.